Okie dokie, let's try to get this. Today you are going to be talking about algebraic proofs. So you will be using algebra to write two-column proofs and then apply your understanding to geometric proofs. Now what the idea here is, I want to make sure I can take this idea of something that you know, put it into proofs, and then try to go work in the geometry stuff. And whether or not we do that today, we'll see. I don't know. Anyways, okay, so you should already have this in the worksheet that was given to you, but here are the algebraic properties of real numbers, addition property, subtraction property, multiplication property, division property, reflexive, all that. Okay, you should already have that, but if you don't, then there you go. Okay, so let's look at something here. So in proofing, we want to identify the reasons for a step. For example, like if I said 5 equals y, then y equals 5. I mean, I'm being able to do that because of the symmetric property, where I'm allowed to switch things. In algebra, you've seen problems like this. 2x plus 5 equals 17, and then you subtract 5 from both sides. If I said 2x plus 5 equals 17, that could be given. Then subtract, I use the subtraction property to be able to tell me I can subtract, and I could continue from there. So there is a slight difference between the way some people will show you certain steps. If you wanted to have the most drawn out steps, as state every little reason that you have, well then here you go. Before here you go, let's talk about this. You could reorganize it into what is called a two-column proof or formal proof. I personally think that once you get used to these are actually easier than regular proofs. Or, I'm sorry, the informal proofs, those paragraph proofs we were doing. They contain statements and reasons organized in two columns to reach a conclusion. Okay? So, you're basically justifying why you do something. For example, alright, so we have this example here where I'm saying 5x minus 3 equals 27, and that's given. Okay, that was given. Because if 5x minus 3 equals 27, then we want to prove x equals 6. Okay, so we start off with our given. 5x minus 3 equals 27. So what would be the first step to solve that? Well, you would add 3 to both sides. And I'm going to show you every single little step. Keep in mind that I've already talked to you about how you can maybe shorten that up a little bit. So we write the plus 3, and that we did by the addition property. The addition property of equality. Okay, so what does that give you when you add 3 to both sides? It gets rid of the minus 3 and just leaves you with 5x, and 27 plus 3 is 30. That is the substitution property that allows me to do that. Okay, and then from there, we can say, alright, well, let me go ahead and divide by 5, and that would be the division property. And then I could say, that would tell me that x is equal to 6, which again, to go from there to that would be the substitution property. Now, keep in mind here, notice that is what we were trying to get to. The way we shortened this up a little bit was we didn't maybe necessarily put the substitution property, but I still wanted you to show me these steps here, like the plus 3 and the divide by 5. So make sure you kind of can be able to do that. How could you maybe do that in class that I would be okay with? Let's look at that. Okay, so how would I like you to do this, but still show me what you're doing? Let's say you took this. If 5y minus 7 equals 2, then equals 7, divided by 2 equals 7, then y equals 3. Okay, so the first thing obviously would be 5y minus 1 divided by 2 equals 7, and that is the given. Okay, from there, what would you do next? Okay, you could show me that you would have 5y minus 1 equals 14. How did I do that? By using the multiplication property. So, how could you show me, but I wanted to say, because right here, this should be the substitution step. So, what if you show me the color, and let's say, dang nab, times 2 times 2. There you go. So, you multiplied by 2 to get that 5y minus 1 because those canceled out, and 7 times 2 is 14. Okay, then you could say, the next step would have been adding 1, and I would have ended up with 5y is equal to 15. Because again, you added 1. You see how I'm also using a different color. That kind of helps me see how you're doing the step. And then you could say, oh, I should have said multiplication property, prop, equality. This would be the addition property of equality. Why won't you let me put a 0? Okay. Okay. And then from there, you can kind of go from there. So that the next step would have been y is equal to 3. And again, this would be from the division property. Division property, equality. And that would be dividing by 5. Okay? So maybe something like that would work. And I mean, technically, because keep in mind, these steps are technically substitution steps based on how like the book would show it. So that kind of gets us going. Now, I think we're going to stick to just the algebraic proofs, and then we will add in those geometric proofs and kind of go from there. So I may add another set of notes with this. But for now, that is it for today. Thank you so much for your time, and y'all take care.